Hi everyone. In this video today we're going to look at how to do some exploratory data analysis for some data sets for your final project. So specifically, I'm going to be showing you guys how to produce some descriptive statistics in some tables and plots to explore your data, which is something you should do like in your report in your final report prior to fitting your models. And some extra stuff that you'll need to include in your paper, along with just the models you fit and the output. These plots and descriptive statistics can really help tell a full cohesive story. And also they're just good analysis skills to know how to do as well. So I'm going to be looking at, just for demonstration purposes, a data set on Netflix TV shows. And I got this data off of Kaggle. So showing you a bit here. This data set, I actually grabbed two data sets and I merged them, although you don't have to do something like that. But there's this data set on Kaggle that was on TV shows that are on Netflix, Amazon Prime Video, Hulu, and Disney+. And so pretty much they have like this data set consists of like a unique show ID, the name of the TV show, the year it was produced, and the target age group, IMDb rating, Rotten Tomatoes rating, and some other measures. Like so these last ones actually in particular, an indicator variable for whether it's on Netflix or not, whether it's on Hulu or not, where 0 is no, it's not available on Hulu, Amazon Prime Video, and then Disney+. So this data set I thought was pretty interesting. And then also there is this other data set, this second data set on Kaggle, a separate one that's on Netflix movies and TV shows, and it has the has some additional variables like the total duration, the TV rating, in terms of like appropriateness, and release year, some stuff like that. So yeah, there's definitely some overlap between these two data sets, but they're not completely aligned because there's movies in this data set, but the other data set was only on TV shows. So anyway, using some code here, I just downloaded the CSV files of those data sets, which you can do by just clicking on the download button at these links. And then there'll be a zip file. You'll just have to unzip it, and then it, which I guess I can show how to do real quick if you want to follow along. You just click on this zipped file after you download it and do extract all. And then if you just extract it, then it has the CSV file that we can then import into R. So we're going to be using the tidyverse package and the knitr package here. I am using these two packages here because I'm actually using R Markdown to make this. I made this HTML file that sort of shows R code and then the output in a nice way. You, of course, are not required to use R Markdown in any way. I know it's a completely new tool, so I'm just showing you this because then the R code is neatly organized with the output it produces for you. So you can still like copy this R code yourself. Anyway, so you'll be using we're using this tidyverse and this knitr package. And so first thing I do is read in these two data sets after downloading and unzipping those zipped files. Okay, and so we can use I used the read_CSV function, which is from the readr package, which is contained in the tidyverse package. And then I specified the file path to the file. Hopefully, I think we've all been able to read the data sets into R for all of you guys. So that's all set. Then a good thing to do always to start is to just look at the first few rows of the data set. So the head function allows us to specify how many rows we want to see. And then this knitter cable function is just printing it into a nice table, nice looking table here. So that's only necessary if you're using R Markdown. Otherwise, you can just use this head command. Okay, so here for the first data set, TV_shows, just like we saw on the Kaggle website, we see it has 1, 2, 3, 7, 8, 9, 10, 11 columns. And we have the IMDb rating, Rotten Tomatoes rating, indicator for if it's on a streaming platform or not, and the title of the TV show and the year it was produced. So looking at the other, before we move on to the other data set, we then will look at some summary statistics for this data set. So to do that, we use the summary function. So just like we used the summary function to look at the model output of a fitted linear model object, R allows you to input just a data frame into the summary function, and then it gives us a bunch of summary statistics about all the variables. So, so here, and again, this knitter, this extra code here in the end is just for R Markdown. So you just need this code here. So here we see that this first variable is just a row ID number, so that's not very important. But the other variables, like, so title, it says, is a character variable, and it has 5,600 rows about, okay, which all the variables do. For year, the year it was produced, we have a minimum year of 1901. Median of 2011, and then a max of 2020. So the newest produced movie was produced in 2020. The oldest movie produced was produced in 1901. So some interesting stats there. The age group is the which age it was produced for or made for. So that's another character or categorical variable. IMDb score is a continuous variable again, so we can see the highest any TV show got in this data set was a 9.6. And importantly, down here, we see that there are 1,161 missing values, or NA values, which stands for not applicable. So there's a lot of missing values in this data set. So we'll have to keep that in mind as we move forward. And yeah, so it's sort of the rest of the variables tell a similar story in that for continuous variables, it gives us the median, the mean, the third quartile, the max value, and so on. So, and if NA shows up here just like this with no count, then there's no missing values for that variable. That's what that means. So here's just some descriptive statistics, which will be good to look at for any data set you're looking at. You'll need to, it's important to look at descriptive statistics like this before just jumping into fitting a model right away. Okay. The second data set, so if I print the first two rows for that, we have some more variables going on here. So we have the show ID, which is just another unique identifier number. We're not very interested in that. The date it was added to the streaming platform to Netflix, so that might be a little bit interesting. We're just going to look at the date it was produced here for this example here. We have the rating, like PG or MA for mature, and a short description. This is sort of an open text description, so that'll be a bit hard to work with given what we've learned to handle in this course, so we'll just ignore that column for now. And then again, I was able to obtain this using the head function. So if you want to see the code, there's these little buttons that show up where the R code is for the preceding output, and you just click on code, and then it shows it to you, and then you can hide it again. Okay, and if you want to like see this button at the top allows you to show all the code at once for the whole HTML document here, or you can collapse it all, hide it all, by using that button. So hopefully this is easy for you guys to use and check out. Yeah, so that was exploring some more descriptive statistics using the summary function for each of the data sets that we're working with here. Okay, so that'll be important for you guys to do as well and include in your report. Okay, so again, you might not have to do this if you just have one data set that's already ready, but I have two data sets that I need to merge. So I just showed how I merged these data sets here and removed some duplicate observations because some showed up twice for some reason with just slightly different like release dates in the data set after I merged them. So I just got rid of those. But again, very specific to this data set, so not really generalizable to yours. But now here's our full merged data set, just the first two rows of it. So we have Breaking Bad as the first entry and Stranger Things, two shows you guys are probably quite familiar with, I'm guessing. We see they both got very high Rotten Tomatoes ratings and also IMDb scores. According to them, according to Rotten Tomatoes and IMDb, Breaking Bad is a better show than Stranger Things, although of course this is subjective. That's just their opinion, I suppose. It's also worth noting, I think like 538, that statistics organization, I think has found when they looked at things, there's a very strong bias in IMDb scores towards what men tend to like. A lot of men do the ratings for IMDb, so or submit ratings, so they're slightly biased towards shows that men would like more. So that's something to keep in mind when we look at these measures. We shouldn't say like, oh, it's a better show just because it has a high rating. It's a bit more complicated than that. So anyway, just something to keep in mind. So yeah, and we still have this description of the shows, a list of the cast, the main cast. So some interesting variables. And again, good to look at some summary statistics after we've merged and to see after we've trimmed down some variables, what we've got, what we're working with here. Okay. All right. So now I remove some columns and convert Rotten Tomatoes to numeric. We see that there's unfortunately a lot of missing values in the Rotten Tomatoes score. So now after merging and removing some variables, we're down to just 450 observations here, but we have 213 missing Rotten Tomatoes scores. Well, that's not good. That's almost half our data here. So that's a problem because when we fit the regression models using the LM or GLM function in R, it only uses complete observations. So if we specified Rotten Tomatoes as like a predictor variable, it would just exclude the data where that's missing. So we would lose about half our data for fitting our model, and that's not great. So what we're going to do is we're just going to drop that column. We're just going to forget about it for now. This is certainly, not the optimal way necessarily to handle missing values in your data set. But just for the sake of demonstration here, we're just dropping this column. So there's like lots of time that can be spent about thinking about how to handle missing values well that we won't get into for your guys' final project or in this course. But just as a heads up, there's methods. They refer to them as imputation methods, where you can sort of use like linear regression or logistic regression type models, or even those models themselves, to just predict what the value should have been that is missing, and then fill that in. That process is called imputation. And there's many different ways to go about that, and pros and cons. But of course, that gets a bit more complicated. So for now, again, we're just going to drop this column. So looking at this data set here, here's some of the most important stuff for your guys' final project. So creating data visualizations. So I know we didn't go over in this course a ton about making plots. We've seen some how to make histograms or scatter plots, but I really wanted to give you guys a chance to revisit that and give you some code directly that hopefully you can use for your final projects to make some nice looking visualizations. So one of the key variables in this data set, potentially for modeling, would be the IMDb scores, IMDb ratings for the different Netflix shows. So this is a continuous outcome. IMDb is. So we are going to create a histogram for this to view the distribution of IMDb ratings. Okay. And so if you're familiar with IMDb, which I'm guessing, again, most of you are, you know that it goes from 0 to 10, I think, for the ratings. So here we can see most of the Netflix titles have a pretty good rating. They're centered at about 7 or 8, with, of course, some really bad, poorly rated ones. And so you can use this code for your own data set. You'll just have to change the data set name and the variable that you want to specify within this AES function, which stands for aesthetics. And then you can change the main title, like I have listed here, the y-axis title, frequency I specified here. And you can do X as well if you wanted to change this, although I just kept it as the default, which is the variable name. There's no units here on my variables for measurement, but for your final project, please remember to use units when labeling these axes. You guys have done a great job of that this semester. I think that's a really important thing to do because it's easy to forget, but lots of times your plots are needing to stand alone and tell their own story, and that's hard to do if the units are missing from the plot. If you have height on the y-axis, it's like, what is height measured in centimeters or inches or feet? It's important, and it's not always obvious, so it's important to label with units when you can. But here again, there's no units for IMDb, so we just keep it as is. Okay, and then the other options on this plot are the call option for color. This just specifies the outline of the bars for the histogram. So I just chose black, and then I think it defaults to the same as the fill color. So the fill color is what the bars are filled in with, which color. So I just picked this color called Dodger Blue here because I like it, I guess. You can pick whatever you want. And again, there's a very nice, I'll just bring it up again, University of Columbia in New York has a nice PDF on our colors. Their stat department does. Okay, and so they show like how I picked Dodger Blue here. Okay, so here they show what that's going to look like. They have all these different kinds of colors you can pick from. So it's really kind of fun. You get to customize your plots and then see what it'll look like. So again, I Googled, like, it's from the stat department at Columbia University. So I just Googled like University of Columbia, and I spelled it wrong, so forgive me. R colors. But yeah, that's something you can do yourself too. Another continuous variable in this data set was the release year, or the year it was produced, I think it might have been, for the Netflix titles. So here, plotting that, oh, this is release year. Yeah, the year produced had much smaller values. So here we can see most of the titles, which is not too surprising, were from 2000 or later, the newer shows. People are just interested in the newer titles, I'm guessing, and Netflix doesn't have super old content because they want to keep people watching it. So, so that's a good plot to visualize there. And then when you have multiple continuous variables in your data set, which you guys should for your final projects, it's very good to create a scatter plot to visualize their relationship with each other. So here again, we have the release year of the Netflix title and the IMDb score. So we can create a scatter plot here, and we can already see this does not look very linear. This is a very weird shape. Certainly some points hanging out here that are likely, if we were to model, say, the IMDb score by the year, they would be very, very influential because they're very far away from the average X value over here. So very influential points here if we were to do that. So just stuff to keep in mind. And it doesn't mean you can't model relationships that are like this when you see this, but just remember what we learned in class, that p-values and confidence intervals are no longer valid when assumptions like this are violated. So anyway, so this is a good way to visualize and explore our data. And again, if you want to see the code for making these types of plots, you can just click on these little boxes up here to see the code. Okay. And this is all, again, using code from the tidyverse package, or specifically the ggplot2 package, which is contained in the tidyverse package. Okay. To make a scatter plot, instead of up here we used geom histogram to make this plot, you can just use geom point to make a scatter plot here. So, okay. And you can use the call argument inside geom point if you want to specify the color of the points as well. But I just left it as the default black. Another thing to look at, another plot that's helpful to create, is when you have a continuous variable in your data set. So again, IMDb's rating, and a categorical variable in your data set. So here we have the age group, the target age group for the Netflix show, and then the IMDb rating for that show, that result. And we can plot it using these side-by-side box plots here. So these show the distribution of the IMDb ratings for each of these target age groups. Okay. And so here, again, here's the code. This is a little bit more complicated to produce this, but hopefully it's usable enough. I want you guys, hopefully I made this for you guys, so hopefully you can make use of it and maybe make some cool visualizations for your own data sets. And of course, I'd be happy to help by email if you ever need any help getting that code to work. So, yeah, so here pretty much what I'm doing is I'm taking my data set. This mutate part of the code here I just did to reorder the levels of the age group. I just wanted it to be all 18 plus, 16 plus, 7 plus to make it in sort of a sensible ordering here. So that wasn't completely necessary, but just makes the plot a little bit nicer, a little bit more readable if we have these ordered, since there is somewhat of a natural ordering to these categories. Then again, I use this aesthetics function inside ggplot AES to specify what the x-axis variable will be, which is age group, called age in my data set, and then the y variable, the response variable, IMDb score. Okay, and then to get the box plots, I just use geom box plot here. And then I added points on top of the box plots, which you don't have to, but I like to see how the points are looking. And then what this is doing, this position underscore jitter dodge, what that's doing essentially is technically, like, if it has a value of 6, these points would be on top of each other, but I can make them just shifted a tiny bit randomly to give this a little bit easier of a visualization to see. So just to make sure all these points aren't on the same exact line and on top of each other, you can jitter them a little bit, give them a little bit of random fluctuation to make it easier to look at the plot here. So that's something people like to do. And then ggplot by default has a lot of extra lines in the plots, like grid lines, to show you. But I don't like those as much, so I like this theme underscore BW for black and white that gets rid of a lot of extra ink, as they say. So yeah, so hopefully, again, you can make use of this code for your own data set to produce some cool plots for your final report. And then this isn't the only categorical variable, age group in the data set. We also have this rating group. So this was like the targeted age group that the TV show was for. And here we have the rating in terms of like maturity, content, how graphic is the content and stuff. So we have not rated, TV mature or R rated, TV 14/PG 13, TV PG, TVG, TVY. So again, I reordered these using this mutate function so that because there's sort of a kind of natural ordering to these levels of the rating again, with unrated or TV mature /R being like the most severe, and then TVY being the most appropriate for all ages, I suppose. And again, just like the code up here before, we use this geom box plot to make the box plots, and the geom point is just adding the points on top of the box plots here. Okay. Oh, and inside the aesthetics function in the main ggplot call above here, when I say fill equals rating, I'm talking about the rating group. That's what causes separate box plots to be produced and gives them each their own color, which is kind of fun to look at. And there's ways to specify what the colors are exactly for these levels as well, or you can just let ggplot choose automatically, which is what I did here. But I'd be happy to help if you were hoping to manually specify the colors and need some help doing that. So yeah, so that's some visualizations we can make for the continuous variables in our data set. And I'm going to post this HTML document on Moodle so that you can, under the Final Project tab, so that you can hopefully click through this and follow along in this video as you go. Okay. Now for the categorical variables in our data set, we're going to pretty much use these bar plots to visualize these things. So again, we look at this rating group variable, which is for the Netflix shows here, ranges from unrated to TV mature /R. So here we can see that over 150 of the observations in this data set correspond to mature or R-rated Netflix shows. So most of them are that way. And then close second is TV 14 or PG 13 shows. So a lot of more adult, older people content on Netflix, and then a few for younger children, I guess. Although, of course, this is just this data set. This is not all-encompassing of every title on Netflix. But and then we had recorded in the data set, if we look back up, we had recorded in the data set an indicator for whether it's on Netflix or not. So all of these are. And then also if it's on Hulu or not. So something can be on Netflix and Hulu and Amazon Prime. It's possible to be on all the streaming platforms or just one. So this is looking at how many each streaming platform have in this data set. So this data set was specifically for Netflix TV shows, but we can look at like how many were on Hulu in this data set, how many were on Amazon Prime. And Disney only had one, Disney Plus, so I just removed that from this data set. And then with this code, which again, I'm not sure, it might be specific to just this data set, but I was able to get the counts for all combinations of which platforms the TV shows were on. So for example, this one's saying it was a show that's on Netflix, not Hulu, not Amazon Prime. There was 351 of those types of shows. Whereas there were 17 TV shows in the data set that were on Netflix and Hulu, but not Amazon Prime. And then so on for the other titles. So the vast majority in this data set are just on Netflix and nothing else. But there's some overlap between the streaming services. Okay, so this was another way to visualize that. And I used the count function to calculate that in R here. All right, and then lastly, I just made another bar chart here, horizontal bar chart, which I made it horizontal using this chord flip function here. It could have been upright. Instead, you didn't have to flip it horizontally, but I just liked to. And Yeah, so this is looking at the number of Netflix shows that were targeted for each age group. So here we have the 16 plus age group, 18 plus age group, and so on. And just like before, you can specify what the color is. So here I said fill color, which I set up here to be medium sea green. So all these plots have medium sea green bars, but you can, of course, customize it to whatever you want. And then, yeah, in terms of the variable name, you would adjust this. I'm using age here, but you would adjust that, change that to your own variable and your own data set name here. So yeah, so hopefully this gives you the tools, the R code that you need to produce some exploratory data analysis for your data set, and maybe give you some ideas of variables you can visualize. Like I said, this will be posted on Moodle, and I'm happy to help troubleshoot if you're having trouble getting some of this code to work for your own data set. I know Thanksgiving's coming up here, so that's exciting. I hope you guys have a good break. So we won't have class this coming Friday, of course, because it's the day after Thanksgiving. But we'll catch up after that the following week. But I hope I'm going to send out a message, an announcement about some milestones, some progress steps we want to make for the final project. So please keep an eye out for that. And otherwise, I'll talk to you guys soon. Thanks.